In Minnesota, a new facility opened that is making green ammonia under real-world conditions. Power from wind turbines powers electrolyzers that split hydrogen from water, another electric system that separates nitrogen out of the air, and a third that combines the hydrogen and nitrogen into ammonia, a critical input for corn farming. The University of Minnesota West Central Research and Outreach Center commissioned the plant earlier this spring and can produce hundreds of kilograms of homegrown ammonia. To understand why fertilizer prices swing wildly, we need to look at how it is made. Most fertilizer today is produced using natural gas. Whenever gas prices go up, fertilizer becomes more expensive almost immediately. Global supply chains also play a big role. Shipping costs, geopolitical tensions, and even seasonal demand can all add pressure. For farmers, this creates a situation where planning ahead becomes more difficult. About 1/3 of the world's urea and 1/5 of its ammonia pass through the Strait of Hormuz, which has been effectively closed to cargo traffic since the beginning of March. Farmers have weathered shocks from the Suez, the Strait of Hormuz, the invasion of Ukraine, and events on the other side of the globe. This is why locally produced ammonia from predictable wind power is such a game changer. Fertilizer has always been a key part of farming. Without fertilizer, yields would drop significantly. Tragically, the current supply shock from the closing of the Strait of Hormuz will likely result in severe famine. The world simply cannot feed everyone without fertilizer. Ammonia is critical to food security. We are witnessing the risks baked into the old system. What used to be a fairly stable farming input has now become something that can change quickly depending on global events. The idea being explored here is actually quite simple, but powerful. Instead of producing fertilizer in large centralized facilities far away, why not produce it closer to where it is needed? If fertilizer can be made near farming regions, it reduces the risk baked into long-distance supply chains and the related market shocks. Minnesota alone imports up to 900,000 tons per year. Today, the cost of ammonia has risen roughly $200 per ton, which means the latest shock has increased the cost to Minnesota farmers by $180 million. This is where wind energy comes into the picture. Wind turbines generate electricity whenever the wind is strong, often in places far from major cities. That electricity doesn't just have to go into the grid, it can also be used for industrial processes. One of those processes is producing hydrogen by splitting water using electricity. That hydrogen is then combined with nitrogen from the air to create ammonia, which is a key ingredient in most fertilizers. So in a way, something as simple as wind becomes part of the chain that eventually helps grow food. For farmers, the most important benefit is stability. Farming already comes with many uncertainties: weather, pests, and market prices. Fertilizer costs shouldn't be another unpredictable factor on top of that. If fertilizer can be produced locally using wind energy, farmers may benefit from more consistent pricing and a more reliable supply. Over time, this could help them plan better, reduce financial risk, and focus more on improving their crops rather than worrying about sudden cost increases. The impact of this approach goes beyond just agriculture. According to Michael Reese, green ammonia research lead at NWROC, it's about 100 times cheaper to store and transport ammonia than hydrogen. So this is a gateway for other hydrogen-based industries. As a stable, efficient use of hydrogen, local ammonia could eventually also supply the raw input to transportation fuels and high-temperature industrial processes like iron making. Work beyond this project continues. A southern Minnesota farming cooperative announced it would partner with a Texas-based infrastructure company, a Minneapolis-based carbon credits registry, and the local power and water utility on a project. This project, located in Blue Earth County, could supply most of the ammonia farmers need within a few years. Modular plants could pump out as much as 12,000 tons of ammonia annually. Talisag, the company behind the technology, says it would be one of the first larger-scale deployments of a modular green ammonia system that makes the local production and distribution of a critical raw material cost competitive and more reliable. Talasag says its approach lowers ammonia costs by up to 50% by freeing production from fragile global supply chains and using no raw materials other than abundant sun, air, and water.